Load planning is the process of arranging freight inside a transportation unit, such as truck, trailer, or container, in the most efficient way possible. Its primary objectives are to maximize the available loading space, comply with legal weight restriction, and ensure unloading at each delivery location is as efficient as possible. So, how does load planning work in SAP TM? The planning process is performed at the transportation document level. During this process, SAP TM calculates an estimated loading plan based on the available loading space of the assigned vehicle. To perform this calculation, the system relies on the vehicle master data, including the maximum weight allowed per axle group, the maximum vehicle weight, and the loading space dimensions. At the same time, every freight unit provides the information required for the calculation, including the package dimensions and the gross weight for each individual package. By combining both sets of information, the physical characteristics of the vehicle and the properties of the freight, the BTM can determine the most efficient loading arrangement while ensuring that all operational and legal constraints are respected. In the next section, we'll explore how to configure these master data settings and see how SAP TM performs load planning in real business scenarios. Before creating the truck resource, we first need to gather the information from the truck's technical specification sheet. We'll need the chassis dimension, cargo box dimensions, and load capacity information. This diagram provides an overview of the data that will be maintained in the system. Great, let's get started. Go to the Find Resource Theory app. Choose Create Resources. Enter the general information, including the resource name, resource class, location, mean of transport, time zone. Under Continuous Dimension, select Mass. Select the appropriate factory calendar. For capacity, enter the truck's maximum payload capacity from the technical specification. In this example, the value is 26,000 kilograms. Next, go to the Capacity tab at the load volume, which represents the cargo box volume. The maximum load volume for this truck calculated is 44.835 cubic meters. Scroll down to Additional Capacity section and enter the corresponding capacity values along with the cargo box dimensions. Now switch to the Physical Properties tab. Under Basic Data, enter the tare weight, which represents the truck's empty weight. In this example, 7,814 kilograms. Next, calculate the maximum gross weight by adding the tare weight and the maximum payload capacity. For this truck, the maximum gross weight is 33,814 kilograms. For the length, width, and height fields, enter the values from the cargo box dimensions. Next, go to the Load Optimization tab. Under Basic Data, enter the cargo body distance, which is the distance from the front of the truck to the front edge of the cargo box. Scroll down to the axle group section. Notice that this truck has 3 axles arranged in 2 axle groups. For the first axle group, select single axle as the axle type. The axle group distance is the distance from the front of the truck to the center of the first axle group. The value is 1.53 meters. Calculate the maximum growth weight for this axle group by adding the maximum allowable load weight on the front axle group to its empty weight. Configure the second axle group. Select tandem axle as an axle type, since this axle group consists of two axles. Repeat the same process to maintain the axle group distance and the maximum growth weight. The axle group distance is the distance between the two axles in the tandem group, represented by the dimension WN in the technical drawing. Finally, enter the calculated maximum gross weight for the second axle group. Go to Resource Viewer Fiori app and search for the truck resource. When you select it, a 3D representation will appear aside. From here, you can verify the physical information. In the same way, you can change the properties and confirm in real time the 3D truck representation change accordingly. For example, let's change the axle type in the second group to 1. Now the second axle group has changed. Let's get it back. When it comes to material master, it's also important to verify that the material contains the required weight and dimensions data. To do this, open transaction MM02 and access the material that will be used for transportation planning. Go to the basic data one view and verify the gross weight, net weight, and volume fields are properly maintained. Next, click on Additional Data and navigate to the Units Measure tab. Here, review the alternative units measure and make sure that the material dimensions are correctly maintained, including length, width, and height, as well as the corresponding weight and volume values. These settings apply not only to finished products, but also packaging materials if they are used during transportation planning. Once we validate this data, we are ready to the next step. Now it's time to configure the load planning profile. Open the Profiles and Settings app. Next, select Load Planning Settings and click New. Enter a name and a description for this profile. We'll leave all the remaining settings with their default values, since they define the standard load consolidation and load planning strategies used by SAP TM. Now let's move on the load planning rules. This is where you define the constraints and optimization rules that the system will follow during the load planning process. For example, you can specify how product should be arranged, the loading direction, the maximum weight allowed per stack, loading orientation, stocking behavior, and many other constraints. In this example, we'll configure only three rules. The first rule is load resource as compactly as possible. This rule instructs SAP TM to minimize the empty space between products by loading the vehicle as efficiently as possible. The second rule is maximum weight per stack. This rule allows you to define the maximum weight that each stack can support. Next, we'll add the rule 2140. This rule tells SAP to group the cargo based on the delivery destination location. As a result, products destined to the same delivery stop are loaded together. Once we have finished configuring the load planning profile, we'll assign it to the planning profile used by our transportation cockpit. Open the corresponding planning profile. Then, under the Profile Assignment section, assign the load planning profile you just created. And that's it. Now we need to prepare the transportation copy layout so that the load planning features, including the 3D resource viewer, are available during the transportation planning. To do this, open the layout definition and edit the layout that you are currently using in the transportation cockpit. First, let's configure the freight order details area. Add a new content. Expand the order details area and select the load plan. Choose the load plan view that displays both the 3D resource viewer and the freight order items. This view allows planners to visualize how the products are loaded inside the vehicle while reviewing the corresponding freight order items at the same time. Next, we'll enable the Create Load Plan action in the toolbar of the freight order list. This gives planner direct access to execute the load planning process from the transportation cockpit. And that's it. Great, now it's time to execute the load planning process using a practical example. Open the transportation cockpit. Make sure you are using the layout that we configured earlier with the load planning components enabled. For this demonstration, I have prepared a set of freight units where each freight unit represents a product to be loaded. These products must be delivered to different destination locations, all within the same transportation order. Select all the freight units and then select the truck resource that we configure at the beginning of this video. Execute the planning process to create the freight order. Once the freight order has been created, open it and navigate to the Load Plan tab. Expand the Load Plan section. You will notice that the truck is still empty, while all the products appear on the side in red, indicating that they have not been yet loaded. On the left-hand side, you can also review the list of the freight order items, together with their current load status. Now let's generate the load plan. If all the planning rules and loading constraints are satisfied, SAP TM will automatically calculate the optimal loading arrangement. Once the process is complete, you will see the products placed inside the truck in the 3D resource viewer. You'll also receive a confirmation message indicating how many items were successfully loaded into the resource. In addition, we can verify that our loading planning rules has been applied correctly. For example, if we select one of the product inside, we can view its detailed information, including its delivery destination. Notice that the products has been grouped according to their destination location, exactly as defined by the Rule 2140. This grouping makes the unloading process much more efficient for shipment with multiple delivery stops. And with that, we have reached the end of this practical guide on how to configure load planning and SAP TM. In the upcoming videos, we'll continue exploring more advanced loading plan features. I hope you found this video helpful. Don't forget to like, share, and subscribe. It really helps keep this channel growing.